Stardust, ein Staubfänger im All. Seine Mission, das Einfangen von wertvollen Sternenteilchen. Zum ersten Mal überhaupt soll intergalaktischer Kometenstaub gesammelt und zur Erde transportiert werden. Jeder Komet wird von Steinchen umgeben, die älter sind als unser Sonnensystem. Wissenschaftler hoffen, so einem uralten Rätsel der Menschheit auf die Spur zu kommen. Die Analyse von Kometen bringt nicht nur wichtige Erkenntnisse über das Leben auf der Erde, sondern auch über mögliches Leben auf anderen Planeten. So nah wie noch nie soll Stardust an einem Kometen vorbeifliegen. Im Schweif des Kometen angekommen, fährt Stardust seine Kollektoren aus. Wie in einem Spinnennetz verfängt sich der Sternenstaub. Die Kometensteinchen sitzen in der Falle. Ist genügend Staub zusammengekommen, klappt Stardust seine Flügel in eine Rettungskapsel und schießt die wertvolle Fracht auf die Erde zurück. An einem Fallschirm schwebt die Kapsel sanft herab, voraussichtlicher Landeplatz die USA. Schnelle Antworten auf die Frage nach der Entstehung allen Lebens wird es allerdings nicht geben. Die Staubfänger kehren nicht vor Januar 2004 auf die Erde zurück.
NASA is headed for a close encounter with a comet. Early next month, NASA plans to launch an unmanned probe called Stardust on a mission to fly by the comet Wild 2. As it passes close to the comet in January 2004, Stardust will unfold a collector shaped a bit like a tennis racket to snare grains of comet dust that astronomers back here on Earth are eager to study.
The whole spirit of this mission actually is neat. We call it Stardust. We're looking for stardust. We're collecting stardust in part from the comet, which formed out beyond Pluto, and it has come in through planetary perturbations into where we can get it to it with a low-cost spacecraft.
Once the dust samples are gathered, Stardust will head for home to drop off the goods. In January 2006, Stardust will fly by Earth and release a re-entry capsule into the atmosphere that will parachute to a landing site in Utah.
As we approach Earth return, we do some trajectory correction maneuvers. This has to hit the right entry corridor with the kind of accuracy that Michael Jordan makes on his best shots.
The goal of the Stardust mission is to better understand the composition of comets, which are as old as the solar system itself, and offer a glimpse at the building blocks of planets. Study of actual samples of comet dust should provide important clues as to how our sun and the planets evolved, and perhaps even how life began.
Stardust was to blast off Saturday, but the launch was scrubbed when an alarm went off. The alarm indicated there was a dip in the current to a radar beacon, and that is used to track the spacecraft as it moves downrange from the launch site. NASA officials say they believe they solved the problem.
There's nothing on the rocket that's not performing correctly. The team feels fairly confident that the systems that they were evaluating were operating normally. The weather looks great tomorrow, and so I think what we're hoping we did is that we did the prudent thing and that we didn't try to press for a launch. We want to understand what we had and get a good launch off tomorrow.
Stardust is to meet up with a comet in the year 2004 and return samples of comet dust back to Earth 2 years later.
2 Minuten vor dem Abheben ist der Start der amerikanischen Raumsonde Stardust abgebrochen worden. Grund dafür war eine Fehleranzeige im Radarsystem. Die Stardust soll aber noch heute Nacht starten, um auf einer 7-jährigen Reise Kometenstaub einzufangen und ihn mit einer Kapsel auf die Erde zu schicken. Die Wissenschaftler erhoffen sich durch die Analyse der Staubteilchen Erkenntnisse über den Ursprung des Lebens.
This is Delta Launch Control at T-minus 20 minutes and holding. We're in our standard 20-minute built-in hold, which is allowing the launch team time to catch up on any tasks or issues. However, there aren't any. It's a fairly quiet count this afternoon, and we're proceeding on schedule. We have a camera on board the Delta second stage, which we see here looking down toward the surface of the launch pad. That will be giving us pictures from liftoff all the way downrange as we pass Antigua and head toward the coast of Africa. We have a short videotape now that shows what that camera looks like when it was attached to the top of the Delta second stage last week. This camera is manufactured by Sony Corporation. It has a 6mm lens, and then the camera itself is enclosed in a protective housing by a company named Crosslink, and they attach the camera to a mounting plate, and then the technicians mate the camera to the top of the second stage. Here we see the technician pointing inside to where the antenna is that actually transmits the pictures back to ground. This is the camera actually being attached to the second stage. And hopefully we'll have good video of that for quite some time. We should be able to see the solid rocket motors separate from the first stage, and we will also see the Delta first stage falling away from the vehicle. NASA Launch Manager Ray Lugo has just polled his team here in the Mission Directors Center, and at this time all of the NASA teams are go for launch today. He'll be passing that along to Flight Director Rich Murphy in just a few moments. And at this time we remain on schedule for a launch at 4:04:15 this afternoon. At T-minus 20 minutes and holding, this is Delta Launch Control.
The Mission Director on Channel 8. At this time, I'd like to conduct a poll establishing our readiness to proceed at the end of the build-in hold. NLM?
NLM is ready to proceed.
DE?
DE is ready.
SD?
SD is ready.
MOD?
MOD is ready.
Roger, thank you.
This is Delta Launch Control at T-minus 20 minutes and holding. We have approximately 6 minutes and 15 seconds remaining in this built-in hold. Latest balloon data for the upper level wind shows that we are go well in tolerance. While the upper level winds are increasing slightly, there's still plenty of margin for today. Once again, recapping what we did to solve our problem from yesterday, we simply changed the way we go about sampling the data from the C-band radar beacon. As the radar interrogates the beacon, we simply take an average of the values, since the beacon is sampled many, many times in the last 4 minutes after the vehicle goes internal. So by taking an average instead of relying on one particular excursion into a red line condition, which is not representative, we're able to still get a very representative accounting of the readiness of the beacon to support. And the reason for the problem yesterday was essentially that it's the first time we've been in this configuration where we've had 2 antennas on the radar beacon, along with 4 radars, all interrogating the beacon at the same time.
FSC. FSC.
FSC. Ready.
Prop 1.
Ready.
Prop 2.
Ready.
PEA.
Ready.
MEA.
Ready.
EEA.
Ready.
VP.
Ready.
ATC 3.
Ready.
Hydraulics.
Ready.
FMA.
Ready.
SSC.
Ready.
SSP.
Ready.
TM1.
Ready.
TM2.
Ready.
VE.
Ready.
ATC 2.
Ready.
RC.
Ready.
OSM.
Ready.
RCO.
Ready.
MIFCO.
Ready.
AE.
Ready.
NSC.
Ready.
Missile Chief Field Engineer.
Ready.
And Launch Vehicle Director.
Ready.
And we just heard the launch conductor polling his team for the readiness to pick up the countdown, which will happen in just about 4 minutes. At T-minus 20 minutes and holding, this is Delta Launch Control.
1 minute of hold remaining.
LCDR, this is LVD. Resume the count at the end of the hold. Roger.
All personnel stand by for release of the hold.
This is Delta Launch Control at T-minus 20 minutes and holding. 45 seconds now away from picking up the countdown, pressing down to the T-minus 4-minute mark, where we will have another standard built-in hold that will have a duration of 10 minutes. Picking up now in 10 seconds. 5, 4, 3, 2, 1.
T-minus 20 minutes and counting.
Confirmation from the test
OSM
conductor.
report second stage destruct SNA-1 and 2 safe.
Safe.
SSC report third stage ignition SNA safe.
Safe.
CLCDR remove red tag from ward bus enable.
Removed.
Ord enable red tag off.
Off.
TC ord enable on.
Board enables on.
SSP top off second stage helium and nitrogen system pressures prior to the end of the last built-in hold.
Roger.
Once the Delta rocket lifts off this afternoon, it will go through Mach 1 at about 31 seconds into flight, and then reach the period of maximum dynamic pressure 45 seconds after liftoff. At 1 minute and 4 seconds into flight, the solid rocket boosters will be jettisoned, and the flight will continue until the Delta first stage falls away at about 4 minutes and 30 seconds into flight. Then the second stage will ignite 4 minutes 39 seconds into the mission, which will be followed almost immediately by jettisoning the nose fairing from around the spacecraft, the Stardust spacecraft, on top of the rocket. We'll begin receiving data from Antigua 6 minutes 15 seconds into the flight, and Tel-4 here at the Cape will continue to supply data for about another minute and 45 seconds before we're relying fully on data from downrange at Antigua. The second stage will cut off at 9 minutes 55 seconds into flight, and there will then be a coast phase of approximately 11 minutes, and then the second stage will be restarted. The second stage will then burn for approximately 2 minutes, separating from the third stage at 24 minutes 27 seconds into the flight, at which time we'll be standing by for the third stage ignition, the solid motor attached to the base of the Stardust spacecraft. Stage 3 ignition occurs at 25 minutes 4 seconds into the mission, and it will continue to burn for approximately 2 minutes, at which time it will cut off, and then at 27 minutes and 19 seconds into the mission, there will be separation from, the spacecraft will separate from the Delta third stage. The spacecraft will then continue to coast until it approaches the Canberra tracking station of the Deep Space Network over Australia, where we expect to confirm that the spacecraft is on course, that we have the solar arrays deployed, and the star trackers are acquiring the proper stars for navigating the spacecraft toward rendezvous with the comet. There are 2 Araya aircraft downrange off the coast of Africa that will help to supply data on the third stage burn, and possibly will also give us confirmation of spacecraft separation. But in any event, the European Space Agency tracking station at Libreville in Africa, east central coast of Africa, will definitely be feeding us real-time data back to confirm that Stardust has in fact separated from the Delta third stage. So at approximately an hour and a half into the mission after launch, we should have confirmation that the Stardust spacecraft is doing well. And we will have a press conference 6 o'clock today on NASA TV to confirm that the spacecraft is well. At T-minus 15 minutes, 35 seconds and counting, this is Delta Launch Control.
Command carrier on.
DSC verify RF link checks complete.
Complete.
SYS verify no record on change list activated.
Verified.
GE at T-minus 15 minutes after CRD power has been applied. Perform T-minus 4 and T-minus 60 limit check on the backup TFE. Report complete on channel 5.
Roger.
T-minus 15 minutes. Mark.
SSC CRD 1 and 2 external power on.
On.
Verify ADS 1 and 2 safe.
1 and 2 safe.
SSP reports second stage oxidizer tank pressure.
177.
Report second stage fuel tank pressure.
133.
Report oxidizer tank cone temp.
57.9.
Report second stage helium and nitrogen pressurization normal.
Normal.
Verify second stage helium regulator lockup pressure go.
Go.
Verify second stage nitrogen regulator lockup pressure go.
Go.
HYE verify first and second stage hydraulics go.
Go.
SSC report the following. CRD1 bat bolts.
31.87.
CRD2 bat bolts.
31.92.
TM2 report the following. CRD1 AGC.
4.9.
CRD2 AGC.
4.9.
SSC report guidance section temp.
71.
TM2 report the following. CRD1 EED1 resistance.
27.4.
CRD2 EED1 resistance.
27.3.
RCO, report to range status. Range ready. Thank you.
T-minus 13 minutes.
Mark. CL CDR ord bus enable on.
Ord bus enable on.
SSC CRD1 and 2 internal.
On internal.
SSC report the following. CRD1 bat bolts.
31.39.
CRD2 bat bolts.
31.29.
RCO, send 1 second CRD self-test standby transmitter.
Roger. Op number 9210. On my mark, send 1 second self-test. 3, 2, 1, mark.
TM2 report self-test complete.
Self-test complete.
RCO, switch to master transmitter and report complete.
Roger. Op number 9210. Bring up the master transmitter. Command carrier switch to master transmitter.
RCO, send 1 second CRD self-test master transmitter.
Roger. Op number 9210, on my mark, send 1 second self-test. 3, 2, 1, mark.
TM2 report self-test complete.
Complete.
SSC CRD1 and 2 external power on.
On.
CRD1 and 2 external.
On external.
Third stage power enable on. stage system external current.
Decimal 11.
Third stage CM transmitter external power on.
On.
Report third stage transmitter external current.
1.44.
Report third stage CM base plate temp.
52.6.
Report command receiver checks complete and acceptable. LCDR.
LCDR, go.
OSM.
Go.
RCO.
Go.
This is Delta Launch Control at T-minus 10 minutes and counting. Just had word from downrange that the two Orion aircraft have both completed successful data flows back to the Cape. We'll have good data from both Orions today. And we're standing by here within about the next minute and a half for NASA Launch Manager Ray Lugo to poll the NASA team for our readiness to proceed this afternoon. Just had confirmation that the radar C-band beacon is on external power, and the critical time for that beacon for our countdown occurs after the vehicle goes to internal power after we pick up the countdown at T-minus 4 minutes. At T-minus 9 minutes, 6 seconds, and counting, this is Delta Launch Control.
It's closed. Vehicle fuel tank press open. Pressurized tank 224 to 30 psig. Then perform the following steps to reset pre-press bank. Pressurized.
This is the NLM on NASA management with a readiness check to support the Launch Decision Authority Conference. NCE.
NCE ready.
SNMA.
SNMA is ready.
NASA MIM.
NASA MIM is ready.
NAM.
NAM is ready.
Stardust PM.
Stardust is ready.
Copy.
T-minus 7 minutes. Arc.
SSC third stage telemetry system and transmitter internal.
Internal.
Prop 1. Report LOX relief plenum pressure.
9.0.
Report LOX relief plenum temp.
74.6.
Prop 2. Verify VE LOX bleeds and LOX start tank binning.
Verified.
Top LOX to 100% and verify 100% LOX flow switch operation 1 time.
Roger. T-minus 6 minutes. Arc.
OSM third stage SMA.
This is the MD on Channel 8. At this time, I'd like to establish our status prior to going to the LDA poll. NLM.
NLM ready.
DE.
DE is ready.
SD.
SD is ready.
MOD.
MOD is ready.
Roger, thank you. LVD, this is MD on 8.
Go ahead.
Can you report on the vehicle status?
Vehicle status is good. Right now, we're all systems are normal. The only thing we're watching is that final into sphere temp. It's at 100.3, so we're going to be in fine shape.
Roger that, thank you.
LCD RFMA, the load relief is complete. The checksum of Charlie 659.
Copy, sir.
T-minus 5 minutes. Mark.
SSC, third stage TM external power on.
On.
Third stage transmitter external power on.
On.
Third stage telemetry system and transmitter external.
External.
OSM launch enable closed.
Closed.
Prop 1 launch enable on.
On.
SSP launch enable on.
On.
ATC-3 launch enable on.
It's on.
Timer at T-minus 4 minutes. Verify the sequencer is holding.
This is Delta Launch Control at T-minus 4 minutes, 8 seconds and counting, standing by to go into the hold at T-minus 4, 2, 1, T-minus 4 minutes.
T-minus 4 minutes and holding. This is a 10-minute, 0-second built-in hold. Sequencer's verified holding.
Sequencer at the end of the built-in hold. Restart the sequencer.
Roger.
PEA, report ready to enable first and second stage T-minus 4 minute limits.
It's the PEA. We're ready for the 4-minute limits.
Copy that. 4
We
minutes.
have, just mentioned here, we've got 100.2 degrees on our nitrogen.
Copy that. 4 minute limits are on.
We've released one additional weather balloon to confirm our upper level winds. However, the last balloon data has been received, and at this time we're go.
LCDR, Prop 2, Channel 1.
Prop 2.
Final functional top off to 100% locks complete. No anomalies, maintaining locks at 99%.
Copy that. Thank you, sir.
Cycling locks tank in.
This is Delta Launch Control at T-minus 4 minutes and holding. Not much conversation on the nets right now as everything is go. We're not working any technical issues. We'll have final polls coming up here in just a couple of minutes. So at this point here in the Mission Directors Center, we have green board all the way across.
This is the NLM on NASA management with the final readiness poll for launch. NCE.
NCE ready.
SNMA.
SNMA is ready.
NASA MIM.
NASA MIM is ready.
NAM.
NAM is ready.
Stardust PM.
Stardust is ready.
Copy that, sir, and will you please report to me when Stardust is on internal power?
Roger that. Stardust PM.
Minutes of hold remaining. NSC, request spacecraft configured for launch.
NSC.
NSC,
Go ahead.
request spacecraft configured for launch.
Following personnel report ready to proceed with the countdown. FSC.
Ready.
Prop 1.
Ready.
Prop 2.
Ready.
TM1.
Ready.
SSC.
Ready.
SSP.
Ready.
ACC.
Ready.
PTO.
Ready.
VP.
Ready.
TM2.
Ready.
Hydraulics.
Ready.
FMA.
Ready.
SYS.
Ready.
AE.
Ready.
ATC2.
Ready.
ATC3.
Ready.
VE.
Ready.
MEA.
Ready.
EEA.
Ready.
PEA.
Ready.
RC.
Ready.
VSE.
Ready.
GE.
Ready.
RCO.
Ready.
MIFCO.
Ready.
OSM.
Ready.
LWO.
Ready.
NSC.
Ready.
And MCE.
Ready.
Okay, all personnel, post-launch securing will be conducted on Channel 5. Flight data will be reported real-time on Channel 2. Following personnel switch to Channel 5 after liftoff is confirmed for pad securing. CLCDR, Prop 1, ATC 2, Prop 2, SSP, OSM, SSC, Talker, FSC, and ATC 3. All personnel, if a condition that exceeds a launch constraint is observed during the final 4 minutes, the observer shall announce hold on the OpsNet Channel 1 and state the reason. All personnel remain on Channel 1 until after launch. In the event of a hold, after T-minus 4 and before T-minus 2, recycle steps will begin in Appendix K, page A003-21. In the event of a hold after T-minus 2 minutes, recycle steps will begin in Appendix K, page A003-18. Appendix K are the yellow pages. In case of an engine cutoff or no vehicle liftoff by T plus 5 seconds, recycle and safing will be performed per Appendix L, page A003-46. And Appendix L are the red pages. TV cameras have been positioned to monitor the bleeds in the lock start tank throughout liftoff. SSC, calibrate third stage TM 2 minutes prior to picking up the count.
Roger.
And SYS item 11.
Roger.
1 minute of hold remaining.
LCDR, this is LVD. Proceed with terminal count at the end of the hold.
Roger.
CLCDR, verify water pressure is 125 plus or minus 25 PSIG.
Verified.
FMA ord latch on first and second stages.
On.
All personnel stand by for release of the hold.
This is Delta Launch Control at T-minus 4 minutes and holding with 30 seconds remaining in the built-in hold. Once we launch today, the voice we'll be hearing from the telemetry station will be that of Skip Mackey, telemetry manager for Stardust. He'll be giving a status from liftoff through spacecraft separation. 10 seconds now from coming out of the built-in hold. We'll have a very, very busy launch team when we pick up. 3, 2, 1, T-minus 4 minutes and counting.
T-minus 4 minutes and counting.
Remote cameras on.
FSC TM1 and 2 internal.
Internal.
Control 1 and 2 internal.
Internal.
SSC CRD 1 and 2 internal.
Internal.
Beacon internal.
Internal.
TM 1 and 2 internal.
Internal.
Control 1 and 2 internal.
Internal.
Spacecraft Mission Director Ken Atkins has told Ray Lugo, the NASA launch manager, that spacecraft is on internal, and said, let's have a wild ride. Stardust is ready to go.
T-minus 3 minutes. Mark.
Prop 1, vehicle fuel tank press open.
Open.
Fuel umbilical purge open.
Open.
SSC SNA 1 and 2 arm.
Arm received.
FSC ord 1 and 2 arm.
Armed.
Word that the balloon data is in for the transonic and max Q regions, and that upper level wind data is green.
T-minus 2 minutes. Mark.
Prop 1, pressurized first stage LOX tank.
Roger.
LCDR pad 8 deck flush on.
Deck flush on.
Minus 110 seconds.
Prop 2, top first stage LOX to 100% level.
Topping to 100%.
Boeing Mission Director Rich Murphy has just given permission to the launch conductor to proceed with launch.
Minus 90.
SSC hydraulic external power on.
Hydraulics external.
HYE check hydraulic pressure go.
Pressures go.
SSC hydraulics internal.
Hydraulics internal.
Minus 70.
RCO report range go for launch.
Range go.
LCDR, this is LVD. You go for launch.
Roger. Minus 60.
Minus 1 minute.
LCDR countdown limit conditions T-minus 60 seconds on.
60 seconds on.
The button will be pushed at launch minus 2 seconds, and the computer will be controlling.
Minus 45.
CLCDR LC-17A launch enable flight.
Flight.
100% LOX.
ATC-3 main power disable on.
Son.
Minus 35.
Beacon and electronics go.
Hydraulics go.
Minus 30. Minus 20. Minus 15.
Stop and go.
14, 13, 12, 11, 10.
8, 7, 6, green board all the way across. 4, 3, 2, We have main engine start, 0, and liftoff of the Stardust spacecraft, returning a time capsule with the elements of the formation of our solar system.
The programs are going in on time. The disturbances that lift up are normal. It looks good. Vehicle looks very good, burning nicely. Main engine and verniers are looking good. On through Mach 1. Rates look good. Attitudes look good. Going through max Q, and everything still looks good. The solids are burning nicely, very symmetrical. And we have solid motor burnout, a nice symmetrical solid motor burnout. We have solid motor jettison. All 4 solids came off. Rates were low at solid jettison. Attitude disturbances were light. Looks like a nice clean solid jettison, and main engine and verniers continue to go well. We're 14 miles altitude, 27 miles down range already. Rates are very light at this time. Attitude disturbances practically 0. Things look very good at this point.
And we'll be looking forward to separation of the first stage at about 4 minutes into the flight. A tremendous applause here in the Mission Directors Center when the solid rocket boosters separated.
Stage 1 guidance is in. Vehicle response is light and normal. We're now 36 miles altitude and 90 miles downrange, going just under 5,000 miles an hour.
You can see the vehicle leaving the coast of Florida.
Main engine and both verniers look good. .47 miles altitude, 157 miles downrange, and 7,500 miles an hour.
And the first stage will separate at 4 minutes 33 seconds into the flight. We're now 3 minutes 50 seconds into the mission.
We have the fuel float switch, the LOX float switch. We have enabled MECO. We have MECO. Verniers continue to burn. We have vernier engine shut down. Stage separation has occurred, and we have second stage ignition. Ignition is normal with an oscillating regulator. Looks fine. Regulator oscillations are damping out. Chamber pressure looks good. Fairing is off and fairing separation look good. No recontact. Chamber pressure looks good. We still have some small oscillations in the regulator, but looks like it's burning fine. Pressures look normal on the second stage. We have very light roll jet activity. We have the MECO orbit page, which is not really in orbit, but it is very, very close to nominal. The regulator has stopped its oscillating a little while ago, and everything looks very normal now in second stage burn. Second stage systems continue to look good. Batteries are good. Pressures are good. Roll jet activity very, very light. Throttle decay is normal.
This picture now being relayed through the Antigua tracking station.
Looks like we're processing Antigua data at this time, and it looks very good. The guidance system says we're probably going to burn about 2 seconds longer than BET, but that could change between now and SECO. Command system has switched to a downrange sight. It looks very good. Everything looks fine at this point. Jet activity remains very light. At this point, we're at 100 miles altitude, 870 miles downrange, and going about 14,000 miles an hour. So it looks like we may be running a couple seconds slow on predicted burnout, but that's well within the nominal range. Continue to be operating at full chamber pressure. However, the helium bottle is getting close to the point where we begin a light tail off.
Second stage will cut off at 9 minutes, 55 seconds into the mission. We're now at 9 minutes mission elapsed time. Nine minutes, 30 seconds into flight.
So predicting a couple of seconds long. Pico, very close to the nominal time. We have shut it down. Hydraulic pressure is coming down. The pump's been shut off. Accumulator discharge looks good. And looks like we have a normal coast attitude. We have jet activity in all axes. Attitude disturbances at SECO were very light, and we appear to be in a normal coast. Now an open loop guidance. We have turned off the airborne CRDs, Command Receiver Destruct System, and shutdown was normal. The vehicle continues to be in a normal coast. Continue to have excellent data from Antigua. Data from Telfor and Antigua both has been superb. We have an orbit, Pico orbit, and it's, somebody pointed out, it's right on the money. We're off in decimal places in all measurements. Looks like it's very, very close to where it should be. That little pitch program go in. Those of you interested in the official range liftoff time, it is 21:04:15 decimal 238. I repeat, 21:04:15 decimal 238. Continue in a normal coast. Data, a little bit of noise on the data now and then. Okay, we had LOS Antigua. As it went over the horizon, all the attitude disturbances were minimal. The gyros were where they should be. We had plenty of gas in the nitrogen system. Jet activity was normal. So we have a normal coast. The quick look calculations of stage 1 propellant utilization looks like we had a fuel depletion cutoff with a LOX residual of about 103 pounds for a propellant utilization of 99.95. Looked like we had about 150 feet per second more than nominal, which is very good. So I had an excellent first stage. At this point, we're writing Orion data. About 4 minutes away from Orion acquisition. A couple 100 seconds away from Orion data. Orion 1 has announced AOS, so we're waiting for real-time data here. We haven't no real-time data as yet. Now we have some light real-time data. At this point, it looks like we have some very nice data from Orion. We had a little bit of dropout. A little bit of noise on Orion, but it's still pretty good data. continue to be coasting normally here, but events are about to start happening. We have all its jets.
Im zweiten Anlauf ist der Start der Sonde Stardust geglückt. Stardust ist zu einer bisher einzigartigen Mission im All unterwegs. Sie soll den Staub eines Kometen sammeln und zur Erde bringen. Um den nötigen Schub für die Reise zu bekommen, muss Stardust erst zweimal die Sonne umrunden.
Die US-Sonde Stardust ist zu ihrer 7-jährigen Forschungsmission ins All gestartet. 5 Jahre braucht die Sonde für ihren Flug zum Kometen Wild 2. Mit einer Art Fangnetz soll Stardust dort Proben aus dem Staubschweif des Kometen fischen.
Mit eintägiger Verspätung haben die USA gestern Abend die Sonde Stardust auf den Weg zu einer spektakulären Weltraummission gebracht. Die telefonzellengroße Sonde soll 286 Millionen Kilometer von der Erde entfernt Staub aus dem Schweif des Kometen Wild 2 einsammeln. In 7 Jahren soll das Material in einer Kapsel per Fallschirm auf einem Militärgelände im US-Bundesstaat Utah abgeworfen werden. Wissenschaftler erhoffen sich daraus Aufschluss über die Entstehung des Sonnensystems.
2, we have main engine start. 0 and liftoff of the Stardust spacecraft returning.
Talk about taking the long way around. The space probe on top of this Boeing Delta rocket will travel 3 billion miles to get from Florida, where it lifted off, to Utah, where it will eventually land. And the trip will take 7 years. Why? Because there's a stop in between. It's a comet called Wild 2 orbiting the sun.
The reason that we're going out to the comet is we believe they were around at the formation of the solar system, and so they have materials from that time in a very pristine state.
The Stardust mission is one of the most complex robotic missions in NASA history. It is the first time the space agency will attempt to return to Earth extraterrestrial materials from beyond the moon.
Vehicle looks very good, burning nicely.
Once out of Earth's orbit, the spacecraft began a journey that will take it around the sun, intercepting the comet in the year 2004. As it crosses the comet's path, Stardust will gather cometary debris using a tennis racket-looking device made of an exotic material. Called aerogel, this material is 98% air.
It's so underdense that it provides sort of a soft catcher's mitt for slowing down these tiny particles that are going very, very fast.
Particles traveling 9 times the speed of a bullet. Because comets are believed to be leftovers from the formation of the solar system, many scientists think comets may contain answers to the origins of life.
They're theorized to be roughly a third rocks, a third ices, and then a third organic materials. And the postulate is that the organic materials could have contributed to the formation of life on Earth.
Once Stardust gathers the cometary debris, it will head home. As it approaches Earth, a sample return capsule will spin free, descend through the atmosphere, and land in the Utah desert, perhaps carrying the answer to the origin of life. For Science and Technology Week, I'm John Zarella.